Like I said, this is review. This is AP exam type material, and this is all no calculator. Now what's nice about this, it tells you it's implicit, which means you're going to use implicit differentiation. It gives you this equation here, x squared y plus y squared x equals -2. Have you ever seen an equation like that before? Probably not. Let me show you what it looks like. I have software. You can't graph them on the calculator because it's not a y equals equation. But I have software, and you can actually download it yourself. It's a very simple software called Padawan, where you can actually graph these things and see what they look like. This is what that graph looks like that. Isn't that interesting? There's the graph right there. Now, bonus question. I want everybody to think for a minute. Notice here's the equation, and notice there is not a piece of graph in quadrant 1. Can anybody tell me why? Why is there not a piece of graph in quadrant 1? Yes, ma'am. You're multiplying the x values to the y values, and you're supposed to get a negative answer. Is there any way you could pick a point in this quadrant, multiply its x times its y, and get a negative value? No way. No way. That's why there's no graph over here. Okay? So, that's what the graph looks like. Is that a function? Definitely not. Okay. We're going to come back to this picture in a minute. But part A says, show that the derivative is this. Boy, is that nice. They actually tell you what your answer is supposed to be. Doesn't always happen on the AP exam. So what I'd like you to do is I'm going to give you a few minutes to start this. What rules do you see that you might need to use in doing the derivative of this?
Product.
You see the product rule? I have an x times a y, and then another y times an x. So we're going to have to do product rule twice. So right now, try to do just the first step of this. Try to do the first step of the product rule right here. And then I'm going to walk around, come back up here and do it. And if you think you can go all the way to the end of the problem, go right ahead. If you want to just do the first step and stop and wait for me, you can do that as well. Okay? So 1 is x squared times d2 is dy dx plus, copy 2 is y, d1 is 2x. That's the first one. Then we do plus, and we do the second one. Copy the first, y squared, times the derivative of x. What's the derivative of x? Just 1. Plus, copy the x, then take the derivative of y squared. 2y dy dx equals the derivative of -2 is 0. Okay, I'm going to clean this up a little bit. X squared dy dx plus 2xy plus y squared plus 2xy dy dx equals 0. Okay. After you take the derivative, the steps that you perform are pretty much the same way all the way across. What's the next thing I need to do? Everything that does not have a dy dx, which are these two terms, need to move over. So x squared dy dx minus plus 2xy, that didn't move, dy dx equals -2xy minus y squared. Okay, now we factor out the dy dx. X squared plus 2xy equals -2xy minus y squared. And then to get dy dx by itself, divide both sides by the parentheses. I'm going to come over here. Dy dx equals -2xy minus y squared over x squared plus 2xy. Okay, I've done all the math. This is the way most of you guys work. You just get so engrossed in what you're doing that you finally get to the end, and then you look and see if it matches what you started with. Now, denominators were great. Denominators look great. Numerators, however, I walked around a couple people that had already done the whole thing. They're like, wait a minute, I got a negative y squared. But I also have a -2xy, and I've got a negative sitting out front. Do you see that? So what did they do? Just factored out the negative. So dy over dx equals negative parentheses 2xy plus y squared over, and let's just turn the denominator around, 2xy plus x squared. And now it matches the problem it's supposed to match. Okay? Bless you. Questions? Okay? So, we found the derivative. What relationship does that have to the graph? All it is it can calculate the slope anywhere I want it to. That's what it's for. Okay? Any more questions on number crunching this thing? Now, the beauty of a good AP question is the fact that even if you mess this up, you need this to do the rest of it. Okay? So even if you mess this up, you still got the correct derivative right here to do the rest of the problem. Does that make sense? And that makes life so much easier for the grader, let me tell you. Okay. So on the graph of the relation whose x-coordinate is -1. And write the equation of the tangent line at each of those points. Okay. A lot of times you read words and you're like, words, no big deal. Let's take a picture, because a picture, I think, is worth 1,000 words, like the old saying goes. Now, looking at that picture, how many points on that graph have an x-coordinate of -1? How many do you see? I see 2. One right here and one right here. Okay? Now, can you picture, and I don't want to draw on it because I need it for third period, can you picture a tangent line right there? It's going to look probably something like close to flat, if not totally flat. Do you agree? What about here? Is that one going to be flat also? No, that one's going to be slightly slanted. It's going to be tangent like right so. So what they want me to do is find out the y-coordinates for both of these. Looks like that one's going to be 2, but I need to be sure that it's not 2.25 or something. And then they want me to write the equation of the tangent line for both of those. Okay? So, let's go back. Pretend like we don't have a picture. Find a point. Find a point. When you're trying to find a point that you know the x-coordinate of, what do you plug it into? The original or the derivative? The original equation. So what we're going to do, the original equation is up here. I need to plug -1 in for x. So we're going to come over here and do -1 squared times y plus y squared times -1 equals -2. Does that make sense on why we're doing that? Find all points that have an x-coordinate of -1. Well, if you're trying to find the point, you need the y, so you plug the y into the original. In the x in the original, excuse me. So let's clean that up. -1 squared is 1 times y is y. Y squared times -1 is -y squared equals -2. Okay. Solve for y. Without a calculator. What do we do? Okay. I've heard 2 answers today. Factor out a y is the most common one that I've heard. Okay? The only thing is, I can't do that. Why can't I factor out a y? Does anybody know?
I don't know, but what I did was I moved the 2 over and made it a parabola factor.
That's what I want you to do. The reason you can't is because this is quadratic. You have to, if you have a power of 2 or more in any problem, it has to be set equal to 0, not equal to -2. Okay? So, since this is a -y, do I want to move the 2 this way, or do I want to move the y's that way? I would rather move the y's to the right, because then I have a positive y squared. So let's do that. 0 equals positive y squared, and then the y turns negative, and the 2 stays negative. We're going to factor this little guy. y. And how does that factor? You tell me. What do you think? -2 and +1. So then we set each one equal to 0. Y equals +2. Y equals -1. Now when we looked at the picture, did we see 2 points? Did we get 2 y values? Yes, we did. Now it says the x-coordinate is -1, so that means that one of the points is -1, 2, and the other point is -1, -1. Let me go look at the picture again. -1, 2, that's that one right there. -1, -1, that's that one right there. We found them both. Okay, but now we need to write the equations of their tangent lines. All right. Raise your hand if you think you know what I'm going to do now. Kyle, go.
For each point, plug into the derivative equation.
And why do we do that?
Because we have to do both points.
Right. I mean, what's the purpose of plugging into the derivative? What does that find for us? Finds the slope for you. Exactly. So we need to find a slope to go with this point. I'm going to draw a line down there. We need to find a slope so we can write the equation. And we find slopes by plugging into the derivative. Exactly. So I don't care which one you use. I'm going to use theirs because I know it's exactly right. So dy dx equals negative outside the fraction, 2 times x is negative 1, y is 2, plus 2 squared, 2 times negative 1 times 2 plus negative 1 squared. Okay, let's clean this up. So I have the negative outside the fraction. 2 times negative 1 is negative 2, times 2 is negative 4, plus 2 squared is positive 4, negative 4 plus 1. So I have negative 0 over negative 3. So my slope is, what, 0. Now that's the one that was at the top and it looked like it had a slope of 0. Now, write in point slope form and stop. Y minus 2 equals 0, parentheses, x minus negative 1. Plus, plus. Yeah, I just changed it. Okay, that one's done. That's the equation of the tangent line for that upper point. Okay, I'm going to stop right now. I want you to find the slope for the lower point, this one here, and then write the equation of its tangent line. Yes, ma'am? Mm-hmm. You could. You write this in really quickly. The slope is negative 1. Y plus 1 equals negative 1. X plus 1. Moving on. Okay. Part C. Find the points or points on the graph of the relation where there is a vertical tangent. Last Thursday in the notes, I told you how we take and find vertical tangent lines. Does anybody remember what I said? No. Set the bottom equal to 0. Vertical is always the denominator. Okay, you set the denominator of the original or the derivative? The derivative. Well, in this case, it's easy to tell because the original doesn't have a denominator. But in some cases, the original equation and the derivative will have a denominator. You need to know which one. You set the denominator of the original equation equal to 0. You find something else. Does anybody know what that something else is? Yes, you find vertical asymptotes if you set the denominator of the original equal to 0. You find vertical tangent lines if you set the denominator of the derivative equal to 0. Okay? They're both vertical. Okay. Now, so denominator of the derivative, here's the denominator. So we have 2xy plus x squared equals 0. We'll set that equals 0. Here comes a very different kind of problem, probably one you've never solved before. That doesn't look too hard. The only problem is we have one equation with two variables in it. And how do you solve something like that? Well, what you do is you solve it the best you can. What is something that I could do mathematically to change the way that looks? Take out an x. Let's do that. We take out an x and we're left with 2y plus x equals 0. Okay? So now, just like the y was a number, you set each one equal to 0. You say x equals 0 and 2y plus x equals 0. Now, because this one says x equals, this one's going to say x equals also. So I have x equals 0 and x equals what? Negative 2y. There are my two answers for this. I know it has y's in it. That's okay. All right? Just move the 2y to the other side. Okay? So, no. So, we have two places. We have where x equals 0 and where x equals negative 2y. Our final answer is supposed to be a point or 2 points. Okay? Right now it's kind of looking like we're going to get 2. Okay? So if I'm trying to find a point and I now know the x coordinate, how do I find the y coordinate? Plug it into the original equation. So the original equation is up here. So we're going to plug in 0 for x. So we get 0 squared y plus y squared 0 equals negative 2. 0 squared times y is 0. Y squared times 0 is 0 equals negative 2. Wait a minute. Is this bothering any of you? A little, not really? No. 0 equals negative 2. Does 0 equal negative 2? No. So what do we do with things like this? You chuck them. They're gone. So x can't equal 0. But let me show you the picture. Look here. Does that thing ever have a point where the x coordinate is 0? Nope. That's why x can't equal 0. Okay? So now we're going to do this other one. X equals negative 2y. Okay? So I need to go back to the original equation and get negative 2y for all the x's. So that's going to give me negative 2y squared y plus y squared negative 2y equals negative 2. Now I have all y's. Oh, I can solve something that's got all y's. Okay? Now be very careful when you clean this up. This is really 4y squared y, which is really what? 4y cubed. And then here plus negative 2y to the what power? Third again equals negative 2. They're both to the third power, so I can combine them. 4y cubed plus negative 2y cubed is 2y cubed equals negative 2. Now, do I need to move the 2 over, or can I just keep going with the y separate from it? I can just keep going. So we divide by 2. Y cubed equals negative 1. Now what? Cube root. Now, do cube roots get plus or minus? No, they don't. Only even roots do. What is the cube root of negative 1? Negative 1. Okay. So now I know that the y coordinate's negative 1. Okay? Now, there are two ways to find the x coordinate. The way that most people would go is go back to the original equation and plug in negative 1 for x and for y and solve for x. The thing is, though, there's a much easier one, and it's right here. It says that x has to equal negative 2 times y. So x equals negative 2 times y, because y is negative 1. So x is what? Positive 2. There's my point. That's my answer. Okay? Any questions? Anybody? Okay. Y'all are very quiet. Last one, it's almost exactly the same as this one. Find the point on the graph where there is a horizontal tangent line. How do you find horizontal tangents again? You set the numerator of the derivative equal to 0. Okay? All right. So, numerator, negative parentheses, 2xy plus y squared equals 0. Okay. Does the negative really even matter? And somebody asked me, well, how do you know the negative goes with the top and not with the bottom? The reason it doesn't matter, because that's like a negative 1, right? If I divided both sides by negative 1, how would it affect the 0? Not at all. So I really don't even need 2xy plus y squared equals 0. How similar does that look to part C? Almost identical. You do it exactly the same way. So go ahead and work on that for a couple minutes. I'm going to come around with your homework paper. Your homework paper is a carbon copy of this with a new equation. Same steps. Okay? And I will bring that to you as you work on this.